manned space program. Ms. Huang Weifen, Chief Designer of the astronaut system of the China Manned Space Program. Mr. Sun Jun, Chief Designer of the Space Station mission at Beijing Aerospace Control Center, and Mr. Zhong Hongen, Deputy Chief Designer of the Space Utilization System of the China Manned Space Program. They will share with us the progress on China's space station construction and answer your questions. Now I'll invite Mr. Hao Chun to give opening remarks. Ladies and gentlemen, dear friends from the press, good afternoon. It is a great pleasure to meet you all, and thank you for your support for China's manned space project. Yesterday, the Shenzhou 13 astronaut crew safely returned to the Dongfeng landing site and returned to Beijing in the afternoon. The Shenzhou 13 flight mission was concluded with a great success, and today, requested by the General Command of the Space Station, we take this opportunity to share with you the progress of the Shenzhou 13 mission and of the construction of China's space station, and also answer your questions. May I first briefly review the process of the Shenzhou 13 mission. On October 16, 2021, the Shenzhou 13 manned spacecraft was launched in the Jiuquan Satellite Launch Center and docked with the core module of the space station. The astronauts entered the core module, and when the astronauts stayed in orbit, they maintained the core module facilities and equipment as planned and carry out 2 extravehicular activities. They also conducted space science experiments and technological tests, gave 2 Tiangong classroom space lectures, and other educational activities. The Shenzhou 13 crew stayed in orbit for 183 days, setting a new record for the longest stay in orbit continuously for Chinese astronauts. The success of the Shenzhou 13 manned mission marked the conclusion of the key technologies verification phase. Right now, the 3 astronauts are in very good physical condition and are recovering in the astronaut center. The construction of China's space station is divided into 2 phases: key technologies verification phase and construction phase, with 6 missions planned respectively. The main objective of the key technologies verification phase is to explore and master the key technologies related to the construction and operation of the space station. Since 2020, 6 missions have been successfully implemented, namely the maiden flight of Long March 5B launch vehicle, the core module of Tianhe, Shenzhou 12 and Shenzhou 13 manned spacecraft, Tianzhou 2, and Tianzhou 3 cargo spacecraft. The success have been seen in all these 6 missions, and the staged objectives have been fully completed, laying a solid foundation for China's space station construction and long-term operation. Since the 18th Party Congress, the Party Central Committee, with Comrade Xi Jinping at its core, has paid great attention to the manned space project. General Secretary Xi Jinping personally visited the mission site many times and met with the representatives of the research and test teams. During the mission, General Secretary Xi Jinping also had a phone call with the astronaut crew. Keeping in mind General Secretary Xi Jinping's instruction and expectation, we made all our efforts to overcome the impact of the pandemic on the research and development and completed successes in a row. Our work cannot be fulfilled without the support of the central and state departments and local governments at all levels, as well as the theater forces. On behalf of the General Command of the mission, I would like to express our heartfelt thanks to all those who supported us and to all our friends from the media for your following and coverage. According to the plan, this year in 2020, we'll complete the construction of China's space station. 6 missions will be implemented. They are: in May, we'll launch Tianzhou 4 cargo spacecraft. In June, launch Shenzhou 14 manned spacecraft. And the crew will consist 3 astronauts, and they will stay in orbit for 6 months. In July, launch the Wentian Ask Heaven laboratory module. In October, we'll launch the Mengtian Dream the Heaven laboratory module. Then the 3 modules will form a T-shaped format, which is the basic format for China's space station, and completing the construction of the China space station in orbit. Then we'll launch the Tianzhou 5 cargo spacecraft and the Shenzhou 15 manned spacecraft. The Shenzhou 15 crew will consist 3 astronauts, and they will rotate with the Shenzhou 14 astronauts in orbit and stay for another 6 months. The year 2020 is the decisive year to complete the construction of the space station and also marks the 30th anniversary of China's manned space project. The completion of the construction of the space station and the completion of the National Space Laboratory is an important goal of the 3-step strategy of China's manned space project, and an important symbol of building China into a strong country in aerospace and science and technology. Facing this new journey in the new era, we're aware of the glorious mission and great responsibility. We'll resolutely implement the important instructions of General Secretary Xi Jinping, meticulously prepare, organize, and implement the manned space project to ensure the successful completion of each mission in preparation for a successful 20th CPC National Congress with real actions. And now I'm ready for questions. Now we'll enter. The floor is open for questions. Please identify yourself before asking questions. Please. With CCTV. Yesterday, the astronauts returned safely to China, and you said this marked the success of the first phase, namely the key technologies verification phase. I wonder what have been achieved in this phase. Are all the goals met? Thank you very much. In my opening remarks, I said that the main goal of key technologies verification phase is to explore and master key technologies related to construction of China's space station. So far, the technologies have been successfully learned and mastered, and the goals could be divided as follows. First, a comprehensive verification of key technologies related to the construction of the space station. For example, we've mastered the support for astronauts' long-term in-orbit stay. Before this mission, the longest stay for astronauts was 1 month, but now it has been extended to 3 months, even 6 months. Also, regenerative environmental control and life support, large flexible combination control flexible solar cell wing, and hand-controlled remote operation and docking. These have laid a solid foundation for the future construction phase. Second, the mission organization and command system was improved. We've entered a period of high density and normalized flight mission. So facing such challenges, in order to ensure success of the project, we further improved the mission organization and command system, established manned spacecraft emergency launch and astronaut emergency return, search and rescue mechanisms. Through the establishment and improvement of the mechanisms, we ensured the successes of the launch missions and the safe and stable operation of the space station and the safety of the astronauts. Third, we established an operation management system with Chinese characteristics. Different from the past, short-term and launch at intervals, now we've entered a period of long-term stay of astronaut in orbit. And this requires a all-time monitoring efforts of the command theater. We developed a combination of centralized and distributed space station operation control mode, as well as in-orbit operation management system. A ground-based flight control support system has been built and put into operation, laying a solid foundation for the following operation management of the space station. Fourth, we achieved high-level space utilization results and significant comprehensive benefits. We carry out space science research and utilization, focusing on containerless materials, high microgravity experiments, and completed a number of successful experiments. Adhering to the purpose of serving the nation and people's livelihood, driving the development of science technology, and enhancing comprehensive benefits, we this time put a number of experimental samples into the Shenzhou manned spacecraft. For example, aerospace, the seeds of aerospace breeding, microorganisms, electronic components, as well as some facilities aiming for deeper and greater experiments in the future. Also, we take this opportunity to launch a series of educational campaigns and programs for young people. For example, the space lectures, the Tiangong classroom, and also the spirit of the times and dialogue between Beijing, Hong Kong, and Macau youngsters. Through this mission, we have comprehensively verified, learned, and mastered the key technologies related to the construction of the space station and tested the functions of the systems in operating their tasks of the space station. We have also tested the capability of operating normalized and high-density tasks and programs. Next question, please. With Restar News. The design service life of China's space station is 10 years, and to ensure the long life and high reliability of the flight products is a serious test to each system component. The core module of the space station has been in orbit for nearly a year. How is its condition? Are the expected goals met or not? And there are many eye-catching components in the key technologies verification phase. For example, robotic arm. What role did it play in the mission? How is its performing.
I believe this question attracts a lot of attention. I would like to invite Mr. Yang to take this question. Thank you for your question. After the successful return of the Shenzhou 13 manned spacecraft, the core module and the Tianzhou 3 cargo spacecraft as an assembly are continuing to operate in orbit in a normal state, and operating parameters are stable. During the nearly one-year operation of the core module in orbit, all planned tasks were successfully carried out, and the rendezvous and docking tasks with 2 manned spaceships and 2 cargo ships were completed. The 3 months mission of Shenzhou 12 crew and 6 months mission of Shenzhou 13 crew, as well as special missions such as extravehicular activities, EVAs, robotic arm transposition of cargo crafts, and manual remote operation have been conducted. And many key technologies have been verified, including the physical and chemical regenerative life support, large-scale combination control, as well as large-scale flexible solar arrays. Assessment shows meeting the expectation results and some better-than-designed outcomes. For examples, during the stay of the 2 crews of Shenzhou 12 and Shenzhou 13, the regenerative life support system on the Tianhe core module provided a good living environment for the astronauts. Their metabolism needs were met with a high degree of efficiency on recovery of the condensed water and urine discharged by astronauts and reprocessing those into drinking water and oxygen. And the figure is over 95%, and water utilization efficiency better than 83%, both meeting the targets. Thanks to the said technology, the cargo craft needed to carry a lot less non-regenerative resources such as drinking water and oxygen for astronauts. Another example would be the flexible solar arrays and the power supply technology. Ever since it's put into orbit, it has been providing sufficient energy. And evaluation shows that the power generation capacity was nearly 10 kilowatts, exceeding the design expectations. And this thus provides sufficient energy for major tasks such as EVAs and rendezvous and docking. Another example would be EVAs. So far, 4 EVAs have been successfully completed, and the operation, installation and maintenance of typical equipment such as EV, electronics, machinery, and pipelines have been completed. The whole process of exiting the module, EV support, and space-ground coordination meet the requirements, laying a solid foundation for the astronauts to install, repair, and maintain EV facilities during the long-term operation after the completion of the space station. At the current stage, we are also doing capability assessment to further tap into the potential of the core module and improve its quality and efficiency. The robotic arm played a great role in the entire phase of key technologies verification. It completed key tasks such as astronauts exiting the module transpositioning of cargo spacecraft and EV status inspection and performed flawlessly. EV operation of the robotic arm showed expected performance on its joint motion and positioning accuracy and other functions. The features of the robotic arm operating load showed that it has the ability to perform large load transfer tasks. At the same time, we also obtained kinematic model parameters of the robotic arm in the orbital weightlessness environment. This has laid a very solid foundation for future tasks such as robotic arm transpositioning, experimental modules, and EV payload maintenance. The core module has finished the tasks of verification and expectations have been met. Thank you.
Hi, I'm from Reuters. I have two questions. My first question is, will the COVID-19 outbreaks in China this year delay the completion of the space station by the end of 2022? And my second question is, how much has China spent on building the space station so far? And how much does China expect to spend in the coming months? Thanks.
好，请翻译一下。
您好，我是路透社的记者，我有2个问题。第一，新冠疫情的爆发呢，是否会推迟今年空间站的完工？第二个问题是，迄今中国在建造空间站方面花了多少钱？接下来预计还会花多少？谢谢。
好，这个问题我来回答。
Thank you very much for your question.
自2020年新冠疫情
Since the start of COVID-19 in 2020, we followed the plan of the country to overcome the difficulties brought about by the pandemic and adopted several targeted measures to offset the negative impact of the pandemic.
这个地方的政府的一些大力的支持和协助，我们把疫情对工
We
程的影
tried
响
our best to
降到了最低。
minimize the impact
目
of
前
the
看呢，
pandemic to our
工程的
project.
进度总体受控，
So far, the
不会影
progress
响空间站建造。
is moving forward as planned, and
要中国空间站
our plan of construction will not be affected by the pandemic.
总体规模适中，
The budget
一直
is
保持
moderate for China's
与
construction of the
社会
space
经济
station,
发展总体水
It is
平相适
in
应的
line
节奏
with the progress of China's
载人航天工程
national and socio-economic
走私路一条
development.
符合中国国情，投入较
We
少，
Used relatively small
发展较
budget
快
to achieve relatively rapid
成
progress
果比较多的
and
可持续的
achieved
富有中国特色的发展道路。
sustainable
谢谢
development and acquired a number of significant outcomes.
好，这是
Thank you.
第400
Next
个
question, please.
对，
谢主持人，新京报记者
From
提
the
问
New Beijing
在载
Daily.
人航天领域呢，通常将测控通信系统
In the field of
视为
manned
关键的
spaceflight,
通讯线
the
在空间
measurement
站
and
关键
control
地面阶段
communication
空间
system
越
is
来越
often
大
called
空中
in
线
the
越来越
invisible
多
kite
如
string.
何做
As
到
the
精
kite
准
is
测
getting
量
bigger and there are
控
more
制
and more
精准
strains,
参针引线确保
what
空间站
measures
安
were
全
taken
稳
to
定运
achieve
行系统
precise measurement and control to ensure the
这
stable
个问题
operation
呢
of the space
请
station?
测控通信系统的孙金富董事回应。
I'll invite Mr. Sun to take this question. Thank you for your question. In the past 2 years, our main task has been to complete the assembly and construction of the space station. Since last year, through the 5 missions for practice and technology accumulation in the key technology verification stage of the space station, we have made breakthroughs and mastered the key technologies for flight control such as rapid rendezvous and docking, automatic mission planning, precise orbit determination and forecasting of spacecraft with complex configuration, and robotic arm control. We have built a nationally produced and stable flight control system platform and built a complete set of space station orbital flight control management system with distinct Chinese features. This shows that now we have acquired the key technologies required in the stage, and this means for this year's space station's in-orbit assembly and construction, effective support will be provided. While carrying out in-orbit assembly and construction, we will also continue to improve the efficiency of space station operation management, optimize the in-orbit support for astronauts, make the flight control system more automatic and smart, and on top of that, expand space sciences application experiments. All of these will help to improve the in-orbit efficiency of the space station and better harness its role as a large platform for space sciences experiment. The Shenzhou 13 crew set a record for duration of stay of Chinese astronauts in orbit in space. In the future, the Chinese space station and astronauts will continue to be in orbit for a long time. According to the mission planning and scientific experiment needs, Our center is responsible for organizing and implementing in-orbit management of the space station, and we've taken measures to ensure the safety of the space station and astronauts in orbit. First, a ground verification system has been put in place. The plans for assembly and construction of the space station and in-orbit management of key flight control were developed with great care. More than 3,000 fault countermeasures were formulated. A large amount of simulation was organized, and we have put in place emergency flight control plans on the joint test environment formed between the spacecraft monitor and control stations and flight control systems before launch, for the purpose of ensuring reliable implementation of flight control by verifying the function and performance of those plans. Secondly, meticulous command throughout the process, in accordance with the principle of unified command and professional support. During the key control stages, experts from various fields were present to provide professional and technical support at the flight control site. During robotic control and EVAs that bear on major control and complicated in-orbit experiments, multiple systems cooperated with each other to closely monitor and evaluate the status and make on-site and science-based decisions on implementation of the various tasks to ensure their smooth implementation. And thirdly, precise monitoring and control was achieved. Relay satellites provided a wide range of telemetry and command coverage for the space station, including the sea, the space, and the ground. Every orbit was effectively monitored. We have built an automated flight control system, and automatic planning was made for all flight control events in orbit. We also used the digital space station for auxiliary health management and intelligently identified false conditions, and on a regular basis conducted physical examinations of the spacecraft to assess its status. Any abnormalities would be dealt with in a timely and effective manner. Relevant drills such as emergency evacuation of astronauts were carried out. All in all, safety has been front and center in the missions. Fourthly, security risks to the station were properly addressed. On top of full-time monitoring of the space station's equipment and astronauts' health, monitoring and early warning of the space environment and space collisions was strengthened, and necessary measures taken to avoid potential collisions. Since February this year, the orbit of our space station has been announced for the world for collision warning calculations for relevant entities. I would like to take this opportunity to express my gratitude to colleagues from all over the world for building a harmonious and safe environment for the Chinese space station. Thank you.
好，请继续提问。好，第一排吧，第一排这位女记者。
谢谢主持人。南方都市报恩世平记者提问。刚也提到了这一次在轨驻留半年，然后也是刷新了中国航
Just now
天
you
员
have
单次任
mentioned
务的飞
there's
行
a record set for the
时长记录。
duration
那请
of
问这一次
stay,
乘组在轨期
6
间
months.
开展的那
What
些工作
work has
经
been
受住了哪些
done
考
and
验
what
相关系统是否
challenges
开
have
展了
been
一些
met?
针对
Has
性的
there
支持
been
保障
support
工作
provided
然后
to
另外
them?
大家也
And
很关
people are
心
also
航
paying
天员
attention
返回后
to
的身体
the
状况
health
如
of
何
astronauts. Can you give us some information on that?
好，这个大家关心的问题呢，我们请工程航天员系统的黄伟芬总设计师回答。
I'll invite Ms. Huang Weifen to take your question.
神舟13号飞行乘组
The Shenzhou 13 crew
圆满完成了各项任务，
flew for 183 days,
他们在轨驻留期间
setting several records when they stayed in orbit. When they stayed in orbit, they had two extravehicular activities, two space lectures, and completed 9 human factors engineering technology experiments, over 40 experiments covering space medicine, space utilization, and completed 80 items of in-orbit data collection analysis, conducted several rounds of maintenance, inspection, and monitoring of and protection of facilities when they stayed in orbit, and also completed in-orbit training and rehearsals and filmed a large number of images and video materials, and not to mention the education programs they conducted when they stayed in orbit. Overall, the 3 astronauts were in good physical and mental condition during the flight. They enjoyed very good cooperation and very fulfilling life and work. They have completed their tasks excellently. Right now, the 3 astronauts are back to the Beijing Space and Astronaut Center. They are in very good physical and mental condition and are now carrying out post-return recovery work. This is the first time for the Chinese astronaut to stay in orbit for 6 months. This is quite a challenge for the whole aerospace system. Before they took off, we give them a lot of intensive training before their flight, and also some psychological preparation and emergency response training to the astronauts. At the same time, we give them very targeted healthcare measures. On the basis of the Shenzhou 12 mission, we improved the support, the in-orbit support for the astronauts. In terms of health protection, we optimized targeted healthcare measures in orbit, allocate additional drugs and medical equipment, optimized weightlessness protection exercise measures, make the exercises more convenient and fun, and we give the astronauts tailor-made exercise plans to make them more resilient and better prepared for their life in space, and also have targeted exercise on specific muscles to better adapt to the conditions in space. We also give them more fresh fruits, vegetables, and more personalized electrolyte drinks, and diversified the psychological support for the astronauts to better stay in orbit. And secondly, the astronauts' life support was also strengthened. We give them more styles of clothes to wear in space and give them better daily necessities and hygiene products, and also give them more entertainment projects and options. At the same time, the astronauts in orbit work protection was also strengthened. The guidebook of astronauts' operation was specified and put into and revised to give them dynamic updating of the astronauts' work plan, timeless assessment of their workload. The project has been successfully concluded, which is a clear proof of our work, and the work and the progress we achieved in the Shenzhou 13 mission will lay a solid foundation for subsequent missions, accumulating richer information and experience for future missions. Next question, please. From TASS. China's space station has identified about 20 cooperation countries, including Russia. By the end of this year, the China space station will be completed and enter into operation next year. I wonder if normal international cooperation could be advanced, considering the complex international situation. Will there be any problems and obstacles? What is China's expectation? Thank you.
I'll take this question. To explore the mysterious universe and develop aerotechnologies is a common pursuit of humanity. It will not be achieved without cooperation of countries around the world. And international cooperation has been a historical trend for the development of space programs. And in China's development of manned space projects, we have been guided by the principle of peaceful use, equality, mutual benefit, and common development. We have signed cooperation agreements with many countries and carried out multiple cooperation projects and made a lot of outcomes. Going forward, we will continue to be guided by that principle and carry out cooperation with all countries that are committed to peaceful use of the outer space, and we are ready and willing to build China's space station into one that contributes to building a community with a shared future for mankind. And we are ready to work with the astronauts and agencies of all countries to contribute to humankind by exploring the universe. With Phoenix TV. Just now, you have mentioned that Wentian and Mengtian modules will be launched and completing the building of the space station. What is the current stage in their development and what role will they play?
Thank you for your question. After completing the construction of the space station, the two laboratory modules will be the main workplace for the astronauts. And in both modules, they can carry out sealed in-module and extravehicular space experiments. And the two modules are both configured with in-module load testing cabinets and extravehicular load installation platform, and also equipped with information and power support and heat dissipation facilities, making the two modules available for space materials, space medicine, space exploration, and other areas of experimentation. The characteristics of the two modules are as follows. First, the Wentian laboratory module, Questing for Heaven. This module is configured with the same astronaut living facilities as the Tianhe core module, including 3 sleeping areas, a washing area, and kitchen and other facilities. And together with the core module, the two modules can support the life of 6 astronauts during the rotation of the 2 manned spacecraft. It is also equipped with a small robotic arm, which can be used alone and also used in combination with the robotic arm in the core module. And the two arms can together complete the maintenance inspection of the extravehicular and in-cabin facilities. In Wentian module, there is also an airlock cabin. And the core module and the airlock cabin will be used for astronauts to conduct extravehicular activities. And there will be a backup airlock cabin in the core module, not cabin. So, when the functions of the core module failed, the Wentian laboratory module will be the main module to conduct experiments to increase the reliability of the space station. Whereas Mengtian laboratory module, there is an airlock module for cargo and an extravehicular experiment platform. So, in the future, the facilities for extravehicular experiment could be transported by cargo spacecraft, and then through this airlock cabin in the Mengtian module, the facilities can be stored on the extravehicular installation platform to conduct extravehicular experiment. So far, the two laboratory modules, their experiments are moving smoothly. The Wentian experiment laboratory module has been completed in Tianjin and will be transported to Hainan launch site by the end of April. And the Mengtian module has completed in Tianjin and is under test. In the future, it will complete a thermal test and regression test. It is also moving smoothly as planned. Next question, please. With Guangming Daily. What results have been achieved of the space utilization system in the key technologies verification phase, and the Wentian Mengtian laboratory modules are scheduled to launch this year? What will be the follow-up arrangement for this system?
I invite Mr. Zhong to take this question. Thank you for your question. During the nearly 1 year in-orbit flight test of the core module, the newly developed payload on the space application system has been running well and stably and in close coordination with related systems. High-quality in-orbit test and application data has been obtained and fruitful outcomes made. First, the new generation integrated space-ground system solution was applied, including the shared support facility solution and the development of major scientific facilities, as well as low latency information transmission solution. This has thus laid a solid foundation for experimental module construction. Second, for the first time, it means high reliability, large bandwidth optical fiber backbone network was put in place. Large capacity distributed data storage and data processing was also available. And we have also made breakthroughs in the scientific experiment cabinets. And third, the container-free laboratory cabinet was China's first and the world's second experimental facility of the kind in orbit. In comparison with the first one, it has higher indicators and stronger experimental capabilities. It has successfully completed experiments on various types and batches of samples. The heating temperature reached above 2000 degrees Celsius. Various novel phenomena had been identified, and in-depth research has been carried out. Fourth, the high microgravity scientific experiment cabinet pioneered the double-layer vibration isolation scheme of magnetic levitation and jet levitation, which achieved a high microgravity level 2 to 3 levels of magnitude higher than the space station platform, as low as 10⁻⁷ squared g, reaching internationally advanced level. It provided necessary experimental conditions for cutting-edge research, such as relativity and gravitational physics. Fifth, for the first time, latency of the space-ground closed loop for application support was shortened to within 2 seconds. And an experimental mode for parallel comparison between the digital twin model and the physical image was established, which effectively supported in-orbit scientific experiments. Going forward, we will continue to carry out scientific experiments in the core module, including the use of container-free materials experiment cabinet. And they will finish in-orbit construction, launch site test, and launch testing. 14 scientific cabinets have been installed. Each and every one of them is a space laboratory. And outside of the module, multiple EV points and EV platforms have been installed. And the Sky Survey telescope has also been installed as a flagship facility. This will enable us to carry out research on space life sciences, aerospace and geosciences, and new space technologies and applications. Over 100 research plans will be carried out, covering over 1,000 projects. This will enable us to study the origin of life and other cutting-edge areas. Major progress is slated to be made, and on space materials science, life science, microgravity, fluid physics, and other major directions, we are expecting progress to be made. This will advance China's relevant research to reach internationally advanced level.
第一排吧。
Was Xinhua News Agency. With the completion of the verification stage, the construction will further proceed. Can you share with us what is to be expected after the completion of the space station?
Thank you for your attention to the manned space project. After the completion of China's space station, the project will turn into a more than 10-year of utilization development phase. Our plan is to launch 2 manned spacecraft and 2 cargo spacecraft every year. Astronauts will stay long time in orbit to conduct science experiment and tests and maintain the space station. To further enhance the comprehensive capabilities of the project, a new generation of manned launch vehicles and a new generation of manned spacecraft will be developed, of which the new generation of manned launch vehicles will be reusable, and the new generation of manned spacecraft will be able to take up to 7 astronauts and have stronger loading capabilities. And also, we're developing the extending modules and cabins of the spacecraft to conduct more experiments and provide better living conditions for the astronauts. In this 10-year-long period, we'll also use the in-module scientific experiment cabinet and the extravehicular load platform to carry out larger-scale space science and research and new technology experiments involving space, life science, and human research, microgravity physical science, space astronomy, and earth science, and new technology, new space technology, etc. Next year, we have the plan to launch China's first Sky Survey space telescope to carry out sky survey observations. And we hope that we'll carry out cutting-edge research in the formation and evolution of the structure of the universe, dark matter and dark energy, exoplanets and solar system objects. There might be a number of major innovation outcomes. We'll also actively explore new models of commercial human space flight and introduce commercial cargo and other social forces to continuously improve the general benefits of space station operation management.
纵观世界载人航天
Throughout the history of the world's space development, the moon has always been
载人航天向更远发展的一块热土。
very
中国载人航天
favored destination for manned space flight towards deep space.
地月空间。
And China's manned space project will gradually move from near Earth to Earth-Moon space and then to deeper space.
我们也开展了载人月球探
And in the
测
process of building the space station, we have also carried out key technology research and discussion of manned lunar exploration. I believe that the 1,000-year dream of the Chinese nation for moon exploration
将会成为现实。
will become reality in the future. Next question, please.
这位吧，第二排。
好，谢谢。
With CGTN, after the successful return of the astronauts, there is a growing interest of the missions that follow. It is understood that there are 2 batches of 6 astronauts to carry out missions this year. And what are the missions for the Shenzhou 14 and Shenzhou 15 astronaut crew? Any preparations have been done?
I'll invite Ms. Huang to take this question. Thank you for your question. According to the task arrangement during the construction phase, the crews for the 2 manned missions in this phase have been selected. At present, the astronauts for Shenzhou 14 and 15 missions are in good condition and actively carrying out mission training and doing various preparations. Both crews will be in orbit for 6 months, and the crew will be rotated at the space station for the first time. That means 6 astronauts will stay together at the same time for 5 to 10 days in the station, and that will be very big challenges for the system. The crew of Shenzhou 14 will cooperate with the ground to complete the assembly and construction of the space station, during which a single module assembly will in time become a 3-module assembly. In this process, 9 formations of the assembly, 5 rendezvous and docking missions, 3 separation and 2 transposition missions will be done. For the first time, they will go into and stay in the Wentian and Mengtian modules and form a manned environment. They will work with the ground to do testing on the 2-module assembly and 3-module assembly and other tests. They will also, for the first time, use the airlock to carry out EV activities, complete the unlocking and installation of 14 cabinets in the modules. The crew of Shenzhou 15 plans to carry out multiple EV activities to assemble, test, and debug the payload equipment in the module, control robotic arms to install payload facilities outside the module, manage and maintain the space station assembly, which would be 3 modules and 2 ships. Both crews will carry out scientific events for educational purposes and other public activities. And according to plan, they will also do dozens of experiments and engineering tests. They will collect flight control data and carry out health monitoring checkup and exercise, and a large amount of work on platform inspection, equipment maintenance, verification, supplies management, and station management. In view of the flight mission during the construction phase, we have made and done targeted training for the crews falling under 8 categories, so that all the astronauts will be fully prepared in terms of their energy, physiology, their mental state, among others. And we have carried out training on the following aspects. First, training on the setting of the stationed state of Wentian and Mengtian modules, and the normal operation of each subsystem, their maintenance, repair, and on station and supplies management. Second, for robotic arm verification and verification of EVA through exiting airlock, training on maneuvering the robotic arms, the simulated weightless water tank, EVA virtual reality, low-pressure environment were conducted. Third, for the remote operation of rendezvous and docking, and manual operation of experimental modules. And fourth, we have also carried out the support training for them to stay in the mission. Fifth, we have carried out a lot of training for them to control the platforms. And over 100 engineering developing tests and experiments, they have been fully involved in the development of the manuals, and we have been increasing their ability to really do the work on the site. In addition, we have also strengthened personalized training and health support and arranged for the two crews to communicate with the Shenzhou 12 and Shenzhou 13 crews many times. We will also further improve on the basis of the Shenzhou 13 mission. The astronauts will enjoy better long-term flight and in-orbit residence support to live healthily, work efficiently, and complete their flight missions successfully.
最后一道题吧，第二排。
谢谢。封面新闻记者提问。我们知道中国载人航天工程经过了30年的发展，今年将完成空间。
After 30 years of development, the space station of China will be fully built this year. What role has such technologies played in improving people's lives? Thank you for your question. The manned space program is truly rocket science, but it also touches people's lives. As well as developing itself, it has been promoting the development of certain industries and economic and social development, so it is closely connected to people's livelihoods. One, on advancing development of science and technology as the most complicated area of science, and with the most intensive technology and innovation. It has been witnessing a lot of technological innovation outcomes, and the technologies have been applied in other areas. For example, the control of combustion heat transfer system of liquid rocket engine has been able to upgrade the industry of gasification of pressurized pulverized coal and domestic waste disposal. It can also effectively increase efficiency of hydrogen fuel cells. The manned spacecraft and stations for the control measurement, image processing, the components and other technologies related to that are also able to drive upgrading of industrial smart control systems. The heat-resistant technology of manned spacecrafts have been transferred into insulation materials. We have all watched the splendid Beijing Winter Olympics. Actually, outcomes of the aerospace technologies were everywhere at the Beijing Winter Olympics, from the opening ceremony to the training gear of athletes. Second, on advancing economic development, China's manned space program, after 30 years of development, has witnessed over 4,000 of its technologies being transferred into a wide array of sectors in the economy. For example, microelectronics, machinery, manufacturing, seeding have all contributed, seeing the outcomes of aerospace technologies. The seeding on manned space ships have contributed directly to a growth of 200 billion RMB, and it has been used in food processing, culture equipment, and biopharmaceuticals, contributing to economic development as well as food security and environmental protection. 3, on improving people's lives. We all know that the supplies that we are very used to, instant food or diapers, they come directly from the transfer of their aerospace technologies. And now more and more technologies will be used in livelihood areas. For example, using space proton crystallization studies can help with the development on drugs for osteoporosis and muscle atrophy, and the development of new materials on space programs can also be used to improve people's livelihoods. In the future, China's space station will also witness research and experiments on space life science, materials science, and fluid physics. And a lot of breakthroughs will be made. On top of that, I believe more technologies of this kind will be transferred and contribute to economic development and people's livelihoods. Thank you very much. This concludes today's press conference. Thank you.